Hi everyone, welcome all our on our today's sessions on NDHB principles. So last time we discussed about the MDDS, where Kishan has walked you through the details around MDDS. So today the focus will be NDHB, but yes, we are open to hear all the questions or anything you want to discuss towards the end of the session. Where we will shift to the meet link. So we'll get started with our session today. Kishan, over to you now.
Thank you, Komal. Uh, so today's session, we are going to cover the NDHM as Komal said. Uh, so could you move to NDHP? Yeah. Next slide, please. So last session we discussed about MDDS standards, and we discussed what all standards were introduced by the MDDS committee. So that described the what part of the standards. And now we are going to discuss the NDHM, which is the authority who is responsible for bringing all these standards and the architecture in place, the implementation part of the architecture. So as you can see this slide, and we discussed it in the last session as well, that most of the systems in the country, they are sort of silo systems. They have their own different architecture, different information architecture, different data models. So because of that, each and every system is designed with their own local identifiers. So there is no identifier which is common across the systems. And because of this lack of global identifiers or unique identifiers, you may say, whenever we are exchanging the data across the systems, each and every application is sending its own local identifier. So there is no alignment of those identifiers per se. And that is one of the sort of a stumbling block in achieving informed decision making, integrated decision making from the data which could be integrated from the different systems. So one is like there is no unique identifier. The other is architecture is different, data model is different, information architecture is different, and different application vendors are using different types of interoperability standards. So because and one of the major thing is lack of semantic understanding of data across the application. So there is no common meaning of data across the applications. We covered it in detail in our previous session. So ultimately, this is the current scenario, and this is still existing. Lot of applications are like that only. So because of that, there are two major challenges which government faces. One is they are not able to drive any data-backed health resource planning. So you may see like in the current COVID condition, government need a lot of insights from the different applications, the data from the different applications, and they need to take the decisions on the resource planning. So that is one of the major challenge in achieving that. The other challenge is, disease burden is very high, and we can't reduce the disease burden and provide any sort of coverage because that kind of insights are not available. Because data integration is a huge problem. And why data integration is a huge problem? Because of all these problems, what we are discussing: lack of semantic understanding across the applications, and no unified data architecture, no unified standards across the systems, and no unified identifiers. So this is the current state. So how to come over that state? NDHB, which is the National Digital Health Blueprint, so that has answer to know that question. So how to make an integrated kind of decision making, integrated decision making from data from different applications, how to reduce the disease burden, how to bring the data architecture across the application so that data exchange could be unified. There could be semantic and interoperability existing across the systems. So that was objective, some of the objectives, I would say, not all the objectives. Some of the objectives of bringing national digital health mission. Yeah. Next slide, please. So, so you may see like we are talking about a lot of standards here. In the last session also we discussed some of them. So India has implemented standards, but these are still in isolated, fragmented pockets so far, because some systems, for example, in all the payer systems, whenever we are sending the claims data, we need that the different payers and the different TPAs, they need to convert that data into the ICD-10. So they are using ICD-10 PCS for that. So there is some bit of implementation of ICD when the TPAs are submitting their reports to IRDA. So that standard is there. Even in the government hospitals and the private hospitals, they need to submit their medical record documents in ICD-10. At least in government hospital, it is like that. So the reporting is done, the reporting of the MRD data, which is the medical record data. So they use ICD-10 there. But if you see a common healthcare application, so ICD-10 is still is not implemented in full scale. So in the partial way, you may say standards are implemented. So EHR committee, brought the EHR standards which were notified in 2016, and the MDDS standards we talked about. So these are also notified in 2018. So all these standards exist there. They are partially implemented. Loing standards are there. We are still working on bringing the interoperability based on Loing standards in India. So a lot of work is going on. SNOMED is there. NRCS, CDAC, is the resource center for, introducing all these SNOMED codes. These are distributed and released by NRCS India. So basically, standards are there, but these are not yet implemented. Similarly, in the facility registry, a lot of different facility databases uh, exist there. So a lot of work has been done there. So NIN project was implemented by the government. So a NIN, unique national facility identifier, was allocated to the different facilities. NHRR compiled a lot of data from the public and private health facilities. Similarly, all these different provider organizations, they developed a Rohini database for the sake of exchanging the facility ID with the payers. So these three databases exist on the facility side, and there's a lot of duplication of data as well. So now the recent national facility registry which has come. So one of the point discussion is how to synchronize the data from these different registries, how to maintain the pointers of the data from all these existing databases into a single place, because registry need to be a single point of source, a source of truth. So all these things are there. So I would say standards are there. It is not like India is completely blank or completely clean out of standard implementation. It's not that. There is a lot of awareness about standards, and partially these are implemented. Some hospitals have implemented standards in their EMR systems, HMIS systems, but others have not. CDAC has implemented a lot of standards in their HMIS system. NIC has implemented a lot of standards in their HMIS system, but on the private side, still a lot of systems exist which do not have any sort of implementation or some partial implementation. So that is the current state. Yeah. Next slide. So, in order to solve all these problems, health data dictionary is the utmost requirement for any country to sort of bring a harmonization across the different information standards. And basically, the health data dictionary describes the mechanism, the way like how these different standards could be published, how these different systems could be harmonized, and if there is a need of implementing different systems, then how like a sort of harmonization could be done, how the mapping between the different standards could be maintained. So that everything is published by the different countries in the form of data dictionary, health data dictionary. And in India, we can say like the metadata and data standard report is our sort of first version of health data dictionary, but it is an evolving document. So all in future also a lot of changes will come in that, lot of updation and addition will happen in that database. So this health data dictionary primarily covers the different parts which are defined in the right hand side of the slide. So it talks about the different identifiers. I think we covered it in the last session also, but yeah, I'm quickly touching upon that again. So we need different sort of identifiers. We need a unique identifier for patients. We need a unique identifier for different providers and the different healthcare professionals like health workers. We need unique identifiers for doctors. So all these different identifiers are needed. Similarly, we need different terminology standards. So we need ICD-10 for diagnosis. We need SNOMED CT. So all procedure codes. So all these different terminology standards, are published in the health data dictionary. Similarly, we need different electronic documents which should be machine readable. We call it e-object in our parlance. So basically, different e-objects already, my colleagues have covered, and they have talked about different e-objects related to provider space and the payer space. And health data dictionary also need to provide a clear and unambiguous definition of the different terminologies which are used in healthcare. So for example, SNOMED also do the same thing as we discussed. SNOMED provide a very clear and unambiguous definition of the different terms. And then different metadata definitions covered in the MDDS document. The communication standards, what sort of communication standards should be. So different vendors are using different type of ways how they are kind of using the interoperability. So some are using HL7 standards, some are using web service model, some are using REST services. And the NDHB report has highlighted the FHIR standard, FHIR. I will talk about it. So this FHIR standard as the messaging standard for the country. Similarly, the different registries, like all these different identifiers come from the registry. So registry is the source of identifier. So the way I spoke, like a patient need a unique identifier, so there should be a patient registry. If a doctor need to be allocated a unique identifier, then there should be a doctor registry, a disease doctor. If a facility need to be assigned a unique identifier, then there should be a facility registry. So the facility, these registries are the source of different identifiers. So ultimately, all these details are compiled in a health data dictionary format. And most of these are covered in the MDDS committee report also, which I requested you. You may please go to the public domain and access those reports. Yeah. Next slide, please. So NDHM. So in the MDDS committee report, there was institutional mechanism was defined towards the end of the report, and they talked about a national, NEHA as a architecture, NEHA as authority basically. So National E-Health Authority, NEHA, which will be responsible for institutionalizing the interoperability standards across the different organizations, and to observe, to monitor the compliance of those standards, to ensure the adoption of those standards. So ultimately, with the same purpose, this NDHM was introduced. So NDHM. So there are three different words we are using here. So one is the NDHM, which is the National Digital Health Mission, and it is a part of Ministry of Health. And there is a word called NDHB that we are sort of commonly using. So NDHB is the blueprint. It's a National Digital Health Blueprint. So this is a compilation of the architecture, the design principles, the building blocks, and the different. It also covered the timeline and the different institutional structure. Part of that report. So that report was published by the government in 2019, the Ministry of Health in 2019. Similarly, we are using a word called NDHE. So NDHE is the National Digital Health Ecosystem. So ecosystem is what we want to achieve. So fundamentally, NDHM is the authority who will be managing the implementation of NDHB, the implementation of the different building blocks defined in the blueprint document, to ensure that the NDHE comes out of that. So a ecosystem is the target, basically. A ecosystem where standards are implemented, there is a well-defined mechanism of exchanging the data, and it is all based on federated architecture. So I will speak about it in detail. So the preface of NDHM, it talked about certain things here, if you can notice. Like it talked about creation of district level electronic databases. So they are talking the federated architecture up to the district level, basically, and even below that. So basically, the district level, there should be different databases maintained. And now recently, the cabinet has approved, some, financial allocation for the setting up of HMIS at the district levels. So that is all the concrete implementation part of NDHM, NDHB, NDHM. And then establishing the federated national health information architecture, that is the target of NDHM. How to roll out and link the different systems across public and private health systems, at the state level and the national level. and then ensuring semantic interoperability based on metadata and data standards and the EHR standards, which are notified by the ministry. So these are the prime goals and objectives of NDH. Yeah, next slide, please. Yeah, so these are the common principles. So the goal of or the objective of NDHM is to achieve universal health coverage in the country through accessibility, inclusiveness, and the affordability, and the so basically these are the prime objectives which have been taken from the National Health Policy 2017. So ultimately, they are talking about inclusiveness. So that whatever technology and whatever architecture is, sort of recommended, that should be inclusive. That should reach out to all the segments of the society. That should be usable equally by a digitally literate as well as a digitally illiterate person. So in our country, they are still, majority of population is digitally illiterate. They are not well versed to use any digital system per se, but they and then a lot of illiterate people also exist in the country. So there should not be any digital divide. The benefits of the solution should reach out to the bottommost population segment of the pyramid, not just a top layer. So that is the goal, that is the objective. It should be accessible. So it should not only be accessible in the metropolitan cities where there's a good infrastructure existing, it should also be available in the hilly areas, the terrain areas, or the desert areas where there is a, very poor internet or no internet at all, or where there is very poor infrastructure. So it should be accessible, it should be reachable to everyone, and it should be affordable. It should be low cost. So ultimately, these are the goals which NDHM has kept in mind. And then another very important point they are talking about is the education and empowerment of the citizens. So patient will be the owner of his data, and a lot of design principles have been introduced, and a lot of building blocks have been introduced to strengthen the patient to be aware of his data. How his data is being shared, how his data is being used. So they are talking about all these things, a PHR framework. I will speak about it. On the technology side, ultimately they talk about a lot of building blocks. I will cover it. And then interoperability is the prime subject of the NDHB, the blueprint. And then it also covers the registries as a single source of truth. And the different registries come up there, which are basically 3 or 4 registries are very important in that, although there are a lot of different registries that can exist. So facility registry is required, a patient registry, or you call it a beneficiary registry, that is required, and then a health worker registry is required. Then disease registry and many other registries will come in time. Similarly, it lays down emphasis on the use of open standards, open APIs, and security and privacy by design. So basically, by design means whenever any vendor is planning to develop a new application, the security and privacy has to start from the beginning. It's by design. It is not something a vanilla layer on top of the product, or you can define it anytime. So they are clearly using the word security and privacy by design. So whenever you are designing an application, you need to be very careful about designing all the aspects of security and privacy. So ultimately, from a historical perspective, this NDHB is the version which has been defined in the India architecture. So India architecture is basically, it talks about one governance in the country. So when we say one governance, it means all these different systems, whether it is in public health or in private health, they should be so connected together in a loosely coupled manner, and there should be a seamless interoperability of data in a semantic manner, so that there is a common understanding of data across. So ultimately, you can get a integrated data sets out of these different applications for whatever purpose you want. You can develop the reporting out of that integrated data set. You can also use the service delivery frameworks for delivering the different healthcare services to the citizens. Once you have these goals achieved, if you have the semantic interoperability implemented, then you can easily define any digital service, and the different service delivery frameworks can be used for delivering those digital services. These are the ultimate goals, and for that we need the open APIs, sort of public APIs which can be developed as a REST web services, and any other vendor or any other person who want to develop any solution or any different mobile apps or web apps, whatever they want to develop, they can use these open APIs to get integrated in their systems and define the features there. So nothing is proprietary out of that. So everything is open source. Everything is based on mighty open standards. Everything is based on open APIs. And fundamentally, security and privacy has been given a prime importance in NDHB. It should be by design. Yeah. Next slide, please. So this is a slide which is briefly covering the scope of National Digital Health Mission. So the basically National Digital Health Mission, which we call NDHM. So the main vision is to create a national digital health ecosystem. So that is the prime objective they have, which achieve the universal health coverage in an efficient, accessible, inclusive, affordable, timely, and safe manner. So I think we have already talked about it. It should be accessible. There should not be any digital divide. It should be equally reachable to all segments of population. So we have to take care of the design rather than expecting the people to understand a very sophisticated design. So you can't expect a person living in Bangalore using the mobile application who's IT savvy. You can't expect a farmer or a labor to be using the app in the similar way. And that kind of expectation you can never have. So you have to design your solutions in a manner that different segments of the population are able to use the benefits out of that app or that solution, whatever you're designing. So that is a prime objective of NDHM. And then they are talking about the data services, the information architecture, and the different infrastructure services to achieve these objectives, to set up the national digital health ecosystem. So whatever is required, these are being defined as a set of building blocks. And you see that the below diagram, you see like the different entities are there covered under two categories. So one side is the governance side, which is the left hand side. So on the governance side, it covers the ministries, the regulators, or the different accreditation bodies. Like for example, we have this, the quality standards we have in India and the different acts and laws. So it covers the different bodies who are the governing side of the entities, and then it also covers the entities who are on the governed side. So, for example, the different public health system institutions like district hospitals or our primary healthcare centers or community healthcare centers. So that, and then in the private health, all these different hospitals, starting from the primary clinics up to the quaternary hospitals, medical colleges, super specialty hospitals, then payers. So payer side, the different payers, the TPAs, and the different hospitals who are using the different healthcare, who are covered under different healthcare policies and providing the healthcare, this thing, claim services. Then the different IT providers, the different vendors who are developing the IT solutions, and the different workers, health workers, or schemes or health missions, or the health information providers, the different doctors. So all these entities are the governed entities. So NDHM is quite all pervasive in nature, if you can see. So it pretty covers everything related to the healthcare dimension. And whatever guidelines, frameworks, are laid down in the NDHM, that pretty sort of covers all these entities on the governed side as well as on the governance side. So it defines the mechanisms, how governance will be set up, what will be the institutional structure, what different regulations and acts are required, basically. And on the governed side, it covers the different design principles, the different building blocks, and the different standards that need to be followed by the different governed entities. So NDHM is basically sitting on top of both these sides. Yeah. Next slide, please. So these are some of the standards I will cover in detail as we will go. So it talks about privacy and security by design. It talks about content and interoperability. So it has gone to the level that it has defined like all these different data sets that need to be exchanged across the application. So what will be the messaging standard for that? What the different e-objects will be there? What will be the structure of those e-objects? What will be the data elements within those e-objects? What are the different value sets? and the code directories that are required for populating the different standards. And so everything is covered in the building block of NDHM. Similarly, the consent has been introduced in the country. Like patient is the owner of his data, so different type of consent methodologies need to be implemented for that. So it can be consent at source, or it can be consent for sharing of data. It can be informed consent, and different policies like opt-in policy, opt-out policy. So everything is coming in the consent related standards. So primarily the patient safety and quality of services. So NDHB, which is the National Digital Health Blueprint, it covers the different standards under this category standard. Yeah, next. So this is a very broad the building block structure which NDHB has introduced. I would not say the architecture, but yes, it is sort of that. So ultimately, it defines the 5 horizontal layers and the 3 vertical stacks. If you can see, so the 5, these different horizontal layers. Each layer is basically talking about a particular aspect of the architecture. When we design the different healthcare solutions and the ecosystem architecture, or we call it enterprise architecture. So all these layers have the equal importance in that. For example, whenever we are designing an application, we have designed a product, so we need to deploy it somewhere. So here the NDHM talks about the health clouds, the secure health networks, and the security and privacy operation center. So basically, on the health cloud side, there is a guideline in NDHB that all the government applications will be hosted on the government clouds, which is the Meghraj, we call it. It is the cloud hosted by Mighty. And similarly, for all the private sector applications, it can be any hybrid cloud. So hybrid cloud is a combination of public and private clouds. So these are different terms actually. You need to understand it. So public cloud, we all know, like Amazon is a cloud, or for example, Google Cloud. Google Cloud has recently introduced their new data center in Delhi, if you are aware, in the July itself. So then, similarly, Azure has their own cloud. So we can take any cloud and we can host our product, on top of cloud. So these are sort of public cloud, because we are kind of hosting our products and solutions on a shareable cloud model, which is shared across the different organizations. So whatever resources we are using on the cloud, it is shared across the different organizations, and it is a cheap option also. It's a very highly scalable option. We sometimes call it hyperscale cloud. But then there are different organizations who have the sort of concerns about putting their sensitive data on the cloud because of this reason, because it's a public cloud, and different other entities data is also existing on the same cloud. Sometimes the competitor data is also existing on the same machine in the cloud where your data is being hosted. So to safeguard, those kind of concerns, most of the organizations keep their data on the private cloud, which is a cloud managed by the organization, or a cloud which is sort of in control of that organization. And ultimately, there is a VPN connection can be set up between the public cloud and the private cloud. So all the outward communications will happen on the public cloud only, and they can leverage the scalability and the network infrastructure of the public cloud. And to make a connection with the private cloud, they can use a VPN sort of connection. So this way, they can safeguard their private data. At the same time, they can leverage the benefits of a public cloud infrastructure. So this sort of model where public and private cloud combine together, we call it a hybrid cloud. So for that purpose, NDHM has laid down, all the health-related solutions will be hosted in the private side on the hybrid cloud, and in the government side they have their own community cloud where all these public health, related applications are already hosted there. So all the health-related applications will also be hosted on the same community cloud, Meghraj, we call it. Similarly, there will be a secure health network for hosting all these applications. So this network, they can use MPLS, which is a multi-protocol layer system, or VPN. So they have to use either of that to secure their network. It cannot be an open network sort of thing. It has to be a secure VPN. So this sort of secure health network is recommended for all the network infrastructure. And similarly, they are providing a security and privacy operations center, which will sort of monitor all the different transactions which are happening, and it will sort of audit and identify all the different sort of what you say, all the deviations basically. So, for example, if let us say a pediatrist is attending the medical record of a adult, so that is not possible because pediatrician by default need to treat only babies. He should not be giving treatment to a man or to adult. So ultimately, if any sort of that thing is happening, that is a breach. That is either a security breach or a privacy breach or some maybe a hacking, or that is a malpractice. So those kind of operations will be monitored and managed and audited using security and privacy operations center. So ultimately, they will have different event correlation mechanisms, AI and the ML tools to sort of capture all sort of events and analyze those events, and based on that, create some kind of a auditing report as well as the monitoring alerts. So that will be the operation of security, and it will cover both. It will cover both. It will cover the security. If there is a ransomware that has attacked some cloud, so that will be noticed by the SOC. We call it in short basically. Security operation control is SOC. Privacy operation control is POC. And sometimes the same operation center can have both the functionality. So ultimately, whenever there will be a breach of security, whenever there will be a breach of privacy, if let us say consent was not given, and without consent, some organization or some third-party organization try to access the data, try to steal the data, that will be monitored by the SOC. So they will have the event correlations. They will have a correlation engine basically. They will have the monitoring tools. They will have the AI ML tools to analyze and detect any sort of deviation that is happening. So that is the roadmap which NDHM is bringing. So you may imagine how strict this entire model is going to be. So nobody can escape the eyes of SOC or POC in future. Similarly, on the database side, NDHB talks about the different identifiers. So as we are already speaking, so all these different identifiers need to be there. So basically, registries need to be there. So different registries will be set up. Some registries may be set up at the central levels. Other registries may be set up at the federated layer by each state. So different registries will be required. Similarly, electronic health record architecture is required, which we call as a health information architecture. So health information architecture is a prime goal of NDHM. So basically, we will talk about HIE, in our subsequent session, next session, and then different health master directories. So along with the registries, you also need the different master data, because this is one of the common challenge in healthcare. Different applications are using their own master tables. So for that reason, MDDS has already identified 121 code directories. So out of that 121 code directives, most of the master table related uh, uh, tables which are need to be maintained in the different applications, healthcare applications, have been identified. And around that, some 70 plus code directories, some data has already been populated in that. Although, as I said, this can never be a final exercise, I can say, or everlasting. It's an everlasting process basically. So it's an evolving process. So more data will be coming in the time over time. But whatever was the understanding that time, so based on that, already 70 plus code directories were populated. So now the different health, different health vendors, IT vendors who are designing these different solutions in the healthcare space, they need to take those master data tables. Either they can make a copy of those master tables in their respective applications, or there will be a master data management solution deployed somewhere by the government. And then we can replicate the master data from there using some open API model. So that solution will yet figure out. So that is a data side thing which NDHM covers. Similarly, on the technology building block side, they are talking about anonymizer and de-anonymizer, because for all these research data, for the aggregation of data, reporting for the reporting purpose, we need to hide the personal information of a patient or a person health identifier information, identifiable information, PHI. So we should not be revealing the patient name or his address or his mobile number or his gender, to any person who is not a care provider of that patient, or who does not have a direct interest in providing any sort of care to that patient and without his consent. So ultimately, this aggregation data, definitely that comes, only when your EHR has already been populated. Only after that, you take the data out and, you sort of populate the data in some sort of data lake, and you create some analytics on top of that. So that data, you never need the PHI of the patient. You never need the personal information. A research person does not need the patient's address or patient mobile number. Most of the time, they are dealing in the aggregated formats only. They are more dealing at the statistical level. They are deploying the statistical techniques to derive their research models. And nowadays, machine learning has come, so a lot of machine models are coming out. So that never need any person identifiable data, and that is useless. So ultimately, you need to hide all that person identifiable information, and for that, you need sort of anonymizer and a de-anonymizer. So I will speak about it more in HI session. Similarly, you need health locker, because a patient can ask for his records and store those records in his own health locker. We call it health locker or health vault. So DigiLocker can be one health locker, for example. It's maintained by MIT. If we add some extra functionality in DigiLocker, that can be one potential health locker. Similarly, consent manager, because patient should be in a position to give the consent. Informed consent should be there. Whenever you are storing and processing the data of a patient, you need to capture the consent. Similarly, whenever you are sharing that data with any other entity, you need to give the consent. And similarly, whenever somebody is doing something with your data at whatever point of time, a consent should come to you. So that consent manager is a component. That is a technical component, basically. That is why it is in the technical building block. Similarly, you need the health analytics solution. You need the GIS servers, where you can tag the GIS server with different registries, and you can provide the features like where is my nearest COVID hospital, who has the empty beds, what is the available beds, where I can get ambulances, where is a available ambulance existing near me, or all these kind of different health related services will be required. So they need to be a GIS functionality for that, and a health information exchange, which is kind of connecting all these different pieces together. So it is one thread which is kind of sort of unifying the entire spectrum of the different entities which are coming up in the entire NDHM. So HI is not just consent manager. HI is not just registry. HI is not just any one single thing. HI is all pervasive. So that is why we have kept a different session to cover that thing. So these are all different technical building blocks. Then application building block, you can develop different applications based on your requirements. So for example, recently, so this healthcare, a lot of apps can be built. So they are bringing primarily two important design principles here. So one is cloud first and the mobile first. So till 2013, 14, whatever, cloud was not the prime importance, or whatever, the different CIOs were maintaining their application. They were only using cloud as a alternative of not buying their own what you call servers and storages, and instead of that, pushing their data and deploying it on some kind of public cloud. So that is a common understanding still today with a lot of CIOs. They think like, okay, in order to convert my capex into opex, I need to deploy I purchase some account on AWS, some account on, for example, any Indian cloud vendor, and I just host my server on a VM machine there, or on a Amazon EC2 machine, and I purchase some network connections and some storage and nowadays this is only a IaaS model, the infrastructure as a service model, which is just one part of the entire cloud offering. If you study the cloud in detail, there are a lot of other solutions which you can deploy on cloud, and different features you can leverage. So there is a PaaS model, which is platform as a service. You can leverage the cloud managed services to develop your own solutions. That is a platform model. Or you can deploy your entire software on cloud and you can provide it as a cloud as a service model. So IaaS, PaaS, and SaaS, these are three different cloud offering models. So ultimately, all cloud first, when we say, it means the basic design of your application should be able to leverage at least the PaaS model of the cloud, not just IaaS model, not just as an infrastructure, but at least you should be able to use the platform as a service feature. You should be able to host your application as a cloud as a service model. That is the meaning when we say cloud first. And whenever you are sitting to design any application, like suppose if I am an architect and I'm designing any application, I should be focused on designing the features in my application which make it cloud ready. Cloud first, basically. So enabling the features to utilize all the platform as a service features from the cloud and able to host my application as a software as a service model. And similarly, mobile first. So whenever we are developing the application, it should be able to be hosted on different delivery channels. It should be able to host on web platform as well as the mobiles. So privacy and security by design, cloud design, cloud by design, or kind of what you call mobile by design. So that is the prime objective, what NDHM is bringing in, because you cannot use the old methods of developing the application if you want to run and sustain the future growth that is happening in the healthcare, in the digital health. So you need to be on the cloud and not just hosting the products on the cloud. You need to be software as a service enabled model. You should be, mobile capable. Your solution should be hosted on the mobile. Most of the people use the mobile nowadays, so there's a greater penetration of mobile in the country. So these are the design principles which, NDHB is talking about, and then you can develop different applications on top of that. And the access and delivery, this is the last building block, this thing layer, top layer. So different applications can be built on that. So you may have the India Health Portal. India Health Portal is already there by MIT. So within that India Health Portal, you may kind of integrate all these different digital services which are delivered on top of all this below 4 layers. Basically, you can leverage all these bottom 4 layers, and you can provide the different delivery, different digital services, integrated digital services delivered through the health portal to everyone. So each and every international country has a health portal for their patients. They have a patient portal. They have a provider portal, except India. In India, it has a India Health Portal, but it is not, sort of that popular yet. Many people are not yet familiar about the existence of that. So more and more services need to be brought in the window of India Health Portal. That Umang portal is there. You might have heard that different ministry services are available through a single window on the Umang portal, Umang apps. So same way, all the health related services could be integrated through the Umang portal. Then a lot of social media app can be there, call center related applications can be there. So all these different applications can be built. And the vertical side, if you see, the one is these 5 layers. The other is health standard. If you can see, is percolating across all the five layers. So health standard, you cannot think like it is related to one layer or other. Whenever you are designing, right from the infrastructure till the access and delivery layer, you need to take care of the different health standards. And health standard is not just terminology standard, is one of that. Health standard is a collection of different standards. I will cover that. And similarly, this unified health communication center, which I spoke about, the privacy and security operation center, that is sort of covering all the 5 layers. So it will monitor the infrastructure, it will monitor the data hubs, it will monitor the technology building blocks, it will monitor the different applications hosted, it will monitor the different ways these application services are delivered. So ultimately, it's all pervasive. So this is a very brief, diagram I've tried to cover here, which sort of talk about the NDHM vision to bring the digital architecture in the country to ensure a unified health coverage. Yeah, that's right. Can you move to next slide, please? Yeah, so I think Supriya already covered this point, when she was covering a topic. So I will not speak much about it. So ultimately, what we are saying is the data sets that need to be exchanged from across the different entities that need to be machine readable and also human readable, I would say. So you can't say like it is only machine readable. So what do you mean by machine readable? I will cover the e-object thing very soon in the next couple of slides. But sort of India is building a common health platform architecture, exchange model, where all these different standard claims in the form of e-objects, the machine readable objects, could be exchanged between the provider and the payer. And even the payers can exchange it further with so within the payer you have TPAs, third party administrators, and the insurance companies. So they should also be able to exchange their whatever data. For example, any transaction above 3 lakh, that need to be handled by the insurance company, not by the TPA. So they should currently they are exchanging all the data through the emails only. So even that kind of exchange should go between the TPA and the payer uh, insurance company organization through the e-objects. Now, similarly, all these payer companies and the TPAs, they need to submit the monthly report to IRDA. So even that report format should go to the IIB platform, the insurance bureau, platform through the use of e-objects. So e-object is all pervasive. So that e-object actually. So this is this slide we are showing you how the interoperability exercises are happening in the country, how the process has already started, the design process and implementation process has already started, where the different providers and the payers will be exchanging their data using standard e-claim formats, and that will be machine readable. So definitely in the backend system, the teams who are the solutions which are deployed on the different payer side and the TPA side to auto adjudicate the claim, they will be able to auto adjudicate it. Currently they are not able to auto adjudicate. That is a manual process. So whenever we submit a form through a mail, this is the current process I'm talking about. They receive it from the email, then one team is sorting that form, the other team is manually entering the data from that form into their backend ERP systems, and then onward, their doctors who are sitting start adjudicating the claim. And in that process there is no fraud detection. There is no, I mean, there are a lot of errors in kind of reporting the data in the ERP systems. Manual errors are there, and the process is lengthy, tedious, time taking. So when the e-object thing will come in, when the interoperability layer will be set up, when this exchange will come in, so this entire process will become automated. Whatever data from the provider system is submitted in the form of claim object through the claim platform, that will be routed directly to the provider, to the payer system, backend system. And the payer system can auto adjudicate that. And they can define the rule engine, which can flag the different claims based on the rules which are defined in their engine, whether this should be passed or whether this need a manual intervention or that is rejected altogether. So those kind of different rules can be set up. They can manage the fraud detection part in that. They can observe the fraud behaviors and they can stop it before adjudicating itself. So all that is a possibility which is currently happening. Excellent. Similarly, on the provider side, the different e-objects have been identified, like discharge summary, consultation note, prescription note. Because we are talking about telemedicine nowadays, so telemedicine, when a doctor and a patient is sitting on the mobile, and doctor is giving the consultation to the patient, you need to submit a electronic prescription to the patient. So that electronic prescription should be definitely in the electronic format. It is standardize the format of that electronic prescription. The e-prescription object has been defined. Similarly, the different hospitals, they are providing a discharge summary. Whenever an inpatient is discharged, it can be a discharge summary or it can be a death summary depending on the outcome of the patient. But that again need a standard format. So one is this e-object is solving the problem of a standardized format that is taken care, across the application, the same format will exist. Two, the different standards, the different value sets which are required, the different code directories which are related to that e-object have been identified and applied. Three, the messaging infrastructure is very simple. It is based on JSON. So JSON can be directly integrated with the form templates, your screens. So there is no need to develop a very robust, very complex sort of system layer to convert your data into e-object. You can design your forms as per the e-object structure, and you can directly take the data from the form to the e-object using some kind of technology like accessibility or whatever. You can use XML, you can use JSON, although JSON is preferable one because if you compare, the size of JSON is quite less than XML. Then you can use the different validation of mechanisms to validate your JSON schema or your XML schema, whatever you have. So ultimately, that will take care of the standardization. This entire thing is done for standardization. These e-objects are the carriers of interoperability. These are the units of interoperability. It's a basic unit, a basic currency. So you have the entire financial economy, but your basic currency is rupee. So once you have defined your rupee value and you have set up a value chain based on the exchange of rupee, then entire financial economy can be erected in the country. So that is the ultimate object. When we are bringing these different e-objects. Yeah, next slide. So if you see NDHB at a brief, what it is doing, one is it is ensuring the compliance of different standards. So in terms of standards, it is ensuring a universal language across the systems. So it has recommended FHIR, FHIR as a standard. All these e-objects are modeled based on FHIR. Within the FHIR, there are different value sets. Value set, if I remind you again, value set is a list of the values which can be accepted by a data element. If it is a multi-value data element, if it is gender, then it will accept M for male, F for female, or T for transgender, for example. And then certain data elements, you need a very large set of values. For example, the diagnosis code. Diagnosis code ICD-10 has been recommended as a code directory for that. So it will accept the value from the ICD-10. Similarly, for all the lab investigations, law and code has been recommended. So ultimately, one is it has notified all the standards. NDHM has notified all the standards that need to be adopted in the interoperability layer. Two, it is ensuring the compliance. So it is building the mechanism how the different entities can be incentivized or de-incentivized to adopt those standards. But that point will come later. I mean, it is just a starting point. Then, this NDHM is talking about building all these different registries as a single source of data and the source of unique identifiers. So we have a patient ID, so PM Modi has already spoken about each and every citizen need to have a unique health ID. So for that, a health ID registry is required, a beneficiary registry is required. So basically all these different registries, the design, everything is currently going on in the NDHM side. Then electronic health records. So health information exchange is required for the interoperability of all these different electronic health record, EHR standards and the FHIR and the e-objects. It defines the different standard formats of what your discharge summary will look like, what your claims related data sets will look like, what your prescription will look like. So everything will be standardized. Similarly, the HI part will handle the automatic referrals. So referral is a very important use case in public domain, particularly. Even in the private domain it is, but public domain it is most. They have the specific referral of hospitals existing across the states. So how the referral, how the inward referral will happen, how the outward referral will happen. And referral is not just the exchange of documents. It is a workflow. How that workflow will be implemented. And then how the data insight from all these different structured data can be there, because the goal of public health is to ensure a resource optimization and forecasting. So ICMR, for example, is doing a lot of disease related forecasting, lot of study analysis they are doing about COVID. They are regularly they are publishing those reports. So at the current state, even ICMR cannot get the data from their another ICMR office through an electronic interoperable manner. So it is all manual. Some sort of IDSP effort has been done in getting some sort of reporting, but that is half-hearted, not fully implemented thing. So once this interoperability framework will be set up in the country, so all these different entities will be able to get the integrated data from the different applications, and all these reporting indicators they will be able to get, so that they can do a better resource planning, they can do better disease management controls, they can reduce the disease burden, and they can ensure the coverage. They can identify who was the poorest section, who is getting maximum time, who has a vulnerability to that sickness. So they can attempt their efforts focused on that segment rather than the better ones, basically. So they can intelligently kind of distribute the resources. We have the scarce resources, we all know, in the country. We cannot have an infinite set of resources. So we need a resource planning, a better resource planning, distribute the resources judiciously. So for that, data insights are. So HI talks about data insight mechanisms. It talks about single source of truth of all schemas, and then this claim engine that is currently being built. So that will bring the electronification of all the claims, the mechanism, so that all these different provider payers and the insurance companies and the IRDA and the different regulators, everything will be completely integrated in the value chain. And that will solve the coverage problem a lot, because that will control your fraud management. That will ensure that with the coverage, with a greater increase in the coverage level, it can handle the volume, the tsunami of the claims that will come actually. And that is one of the biggest financial lever for the providers, because they will get their claims handled in a very lesser tact. So those things, NDHM is working on, and some of the things are already there, have come. Some are coming as a consultation, some will come. So that is the current process. Next slide. So I think institutional framework we have already talked about. This is another part. This is the last chapter in the NDHB, the blueprint document I'm saying. It talks clearly about the governance and the implementation. And the success of any technology implementation requires a very strong governance model. For example, this thing, GST. So GST success is not just the success of technology. Success of technology is, some part of that. But biggest success is the conciliation between the different states and the centers over the agreement on the GST rates, over the distribution of the reimbursement of the money proceeds which is coming out of. So every single payment that we do, there is a clear separation of this is the CGHST, this is central, this is the state. So all these different GSTs are defined. And this entire framework is sort of completely electronic. So all these GST invoices are electronically submitted by the different traders. Each and every GST document, the invoice document, everything has a well-defined schema. So all these things. So but it has a strong governance and the implementation model. The same way, NDHM is bringing a governance model in the healthcare domain to ensure the success of healthcare, health information exchange. Yeah. Next slide. So these are the different recommended standards. So basically, NDHB talks about MDDS standards in detail. It talks about EHR standards, and most of the standards have come from the either of that, either EHR standards or MDDS standards. So for consent management, they are recommending the ISO 17975 standard. And they are also talking about a consent framework based on the mighty open standards. Similarly, they are talking about FHIR as a FHIR release 4 as a standard for the messaging interoperability. So you don't need a simple web service. You don't need a HL7. FHIR is another variant of HL7, which is very simpler, because it is JSON format, so you can integrate directly with the your web forms, or you can integrate it with your machine layer. I mean, your middleware layer, whatever way you want. Then on the still images side, it talks about the PDFs and the JPEG and all. But here, one point I want to add, because Mighty talks about the open standards. So I think they can use the open standard data there. You have the open word document library. So PDF, PDF, if you want to leverage the features of PDF, you need to pay. So far possible, you should have the open source, comparison. I mean, the additions of these different technologies. You have an open source edition of Word, which is called Open Word. Similarly, you can take an open source version of PDF. And then the different formats like OGG video format, or MOV format. So again, this MOV format is proprietary. So they should recommend the open source standard as much as possible. So basically, these are few of the things which I think and NDHM can correct. So like OGG Vorbis they can use for all the audio thing, and the OGG Theora, sorry, THEORA, that they can use for the video. That does the exact same thing, but it is all in open source. So those things you may use. Then diagnostic images, for example, your radiology images or CT, MRI, for example, or the X-rays. For that, DICOM standard is should be used as a embedded binary format in the FHIR standard, FHIR resources. Terminology standards they are talking about SNOMED city, but different places we are recommending other standards also coexisting, and there should be a mapping, a cross mapping between the different standards wherever it exists. For example, all this financial related data on the payer side, they need ICD-10. For the procedures, they need ICD-10 PCS. For the billing side, IRD has already published a standard billing codes, and those cannot be neglected because those are being used by so many hospitals. You cannot ask those hospitals to stop it and suddenly start using something else. So wherever possible, you should have a cross mapping exist, which can convert one format of standard into another format of standard, if it is possible. So for example, it is possible to convert ICD-10 into SNOMED, or sometime so you may use ICD. Some places it can mappings can be provided for ICD-10 to 11 also. Right now it is 9 to 10. ICD-9 to the ICD-10 is available, but in future when 11 will come, the cross mappings will be available between ICD-10 and 11 as well. So if some hospital is using ICD-10, some other hospitals started using ICD-11, so they can use a cross map to sort of to map the codes from the different standards. So those kind of mappings are required. And then on the security side, they talk about digital certificates, they talk about transport layer service, SSL, and SHA 256, AES 256. These are all different encryption protocols which need to be followed by the different applications. And security is not just interoperability security, it is the application security basically. So all these different controls like access control, audit mechanism, the role-based privilege management basically. So there is a particular ISO 22600 standard exists, which is recommended by the EHR standard. So that can be recommended. So wherever possible, NDHB is publishing the relevant standards. And as a provider, the different organizations can take those standards and implement in their respective system. Yeah, next slide. So I think we have already spoken about registries quite a lot. So registries are the source of identifier, and most of these 3 or 4 important registries, facility registry, person beneficiary registry, and the health worker registry. This is also called as a health professional registry, and the disease doctor. So all these registries will be implemented by the center, and rest of the registries like disease registry, those will be implemented by the respective states. But there has to be a clear mechanism defined how the federated architecture will ensure the distribution of the registry data across center and state. What sort of APIs will be provided? How the distributed query mechanism will be implemented? So some of these things will be I will explain in the HI session. So ultimately, these registries are the single source of truth of data, and this is the source of the unique identifiers. Yeah. Next slide. Yeah, next slide. So I think we have spoken. I have already spoken about the claim object and the discharge summary object. So E object is basically one is it is an electronic object that is a unit of interoperability, that has a standard format, that has standard value sets and the code tables assigned to the data elements. And the specific thing is we are recommending MDDS because MDDS is more closer to the Indian requirement that has been identified based on Indian requirement. So right now, the FHIR, the vanilla FHIR cannot be implemented as is for the Indian requirement. NRCS has already developed a profile specification for most of these objects. So what we have done is we have identified the India specific value sets that need to be implemented on top of that. So either NRCS can make the changes in that, or somebody. So we have given the design, somebody can implement that and publish it for the entire country. So when we are kind of publishing these standards, we have to also take care of providing the validation and sort of verification tools also, so that whoever entity is receiving the message or sending the message, they should be able to validate and verify that this message is in the correct format. It is complying with all the different value sets that come across that has been defined. It has a proper structure. And so far, so possible, there are vendor specific custom data elements also. So that should be used to a minimal level only, because most of the minimum data set that is required for the interoperability across the country, that has already been identified as part of the standard e-object structures. So these are machine readable, so you don't need to read it. It's in the JSON format. It will hit your backend engine. The backend engine will process the e-object and will automatically populate the data into different tables. Or if you want to display it on the screen, then XSLT tools and different tools are there, which can and if it is JSON, then you can directly integrate it in the JavaScript diff sections. Basically, you need not to do anything much about it. So that can be displayed on the screens also. So the structure of this different e-object is basically taken based on the standard continuity of care document structure. So continuity of care document was implemented as a SOAP XML object. So it had a header and it had a detail. So basically, if you study the SOAP architecture, SOAP, so it is an envelope structure. Within the envelope, it has a header and it has a detail body. Same way, we modeled these different objects. So each e-object has a header and a detail. Now, within the detail, it has some part of the detail which is standard across the different systems. That will not be changed because it is a minimum data set that is needed. And if anyone want to add on top of that and want to extend that data set using their own custom element, and they can use the custom segments as well. So custom segment is similar to the JAD segments in the HL7. If you are aware of the old HL7 version 2 technologies, then JAD segments and JAD fields we can use for creating our own vendor specific custom data elements. So that provision exists there. So as an entire envelope object, this entire E object will carry the different data elements, and within the data element, it will carry the values from the different value sets and the code directory, and that you can use as a carrier of interoperability data from one entity to another entity. So primarily, all these E objects will be the you can say, as I said earlier, also it is a basic currency of interoperability exchange. Yeah, next slide. So I think I've already spoken that point. So you may move to next slide. So this is you may see like the claim object. So claim object, the header part, it identifies the minimum information to route that object basically. So whenever you are routing, you need to tell like this is the source where from the object has come. This is the provider organization ID. This is the target, which is the pair. So this is a pair ID, where it need to be routed. And this is the person whose this claim is related to, which is the patient or the beneficiary. So this is a beneficiary ID. So most of the time it is a different IDs that are part of the header, and these headers are encrypted using the digital certificates of the claim exchange platform. We call it SCP. And this is also digitally signed. So the hash value is kind of sent across, which will ensure the non-repudiation of these different claim objects. Similarly, the detail part, it will have the different segments like the clinical or the billing related summary or the pre-auth related detail. And the provenance resource in the FHIR that contains all the data elements related to signatures, the digital certificates of the entity who has signed that claim, who has prepared that claim. So all that thing. And all this different detail part, that is encrypted with the key, with the digital certificate key of the respective payer systems. so that in between nobody can open that data. And the hash value is also sent. These are digitally signed, so hash value is also sent to ensure key when the object is reaching to the payer, so no kind of tampering of that object has happened in between. So this is to ensure the greater degree of trust in the usage of the claim object, because it's all money related. And for that, the registries, the NDHM will provide the different registries and the identifiers. API design is currently going on, which will ensure that different open APIs will be provided for exchanging the data between the payers, providers, and the insurance systems. Policy markup language is primarily not used in the SCP per se, but it is used on the provider side to sort of read the different policy documents in a machine readable format. And you may also go and further and validate those different policies, or maybe execute those different policies. So it's a machine readable format of the different policy documents. And then on the payer side, you need the different rule engines, which once it receives the claim electronic object, it is able to run all these different, it is able to fire all these rule triggers and sort of put the claim in three buckets, whether it is approved, or whether it requires a manual scrutiny, or whether it is rejected. And it should also be able to flag any claim which is sort of spurious or kind of a fraudulent claim. So for that, a lot of AI, ML related data insights can be built uh, in the payer side systems. So this e-object will sort of help streamlining this entire process, because it will ensure auto adjudication, it will ensure fraud detection, fraud management, it will ensure even the anonymous the claim data sets that can be used for the policy analysis purpose also, like how many claims of a particular category were handled. So all those numeric indicators, or you call the different reporting indicators, can be generated on top of that. And that can be sent to PMJ, that can be sent to NHA, that can be sent to IRDA, that can be sent as a public data domain. It can be, the open APIs can be provided, which can be accessed by the different research scientists as well, researchers as well. So that is the current work which is happening in the SCP side. Next. So microservice is a little bit technical architecture. I will try to make it a simpler one. So one of the fundamental thing which NDHM talks about is the scalable architecture. It require a broad next. So two or three things I already covered. Let me repeat it again. So one is it require a cloud first strategy to be implemented by all vendors, so that application should be able to use the hyperscaling features of the cloud. It should be highly scalable. It should be able to handle any volume of load, be it 100 user or be it the entire nation. I mean, if you have a pan India application and all of a sudden everyone wants start putting the orders through your application, it will become a pan India. So it should be able to handle the load. Two, it should be able to leverage the platform as a service features of the cloud. Three, you should be able to deploy your application as a cloud service, software as a service model. So for that, you need the cloud first strategy. You also need to build the mobile first strategy, so that your same application, when you're designing it, same time it should be accessible through different access delivery channels. It can be accessed over mobile. It can be, and mobile you have to always keep in mind, because most of the people are using mobile nowadays. Nobody is going and sitting in front of laptop and opening a web browser to open the application. So fundamentally, to cater this requirement, a different kind of architecture pattern was required, which was first identified in the India architecture, which defined the enterprise architecture of the country. And NDHM is a subset of that India architecture. So ultimately, this microservice architecture, as the name is telling, micro means small. So when you are building any application, any system, the older mindset is you develop the entire application as a single monolith, and you deploy the entire application on a single server with a single database. And within that application, you can develop layers. You can have a database layer, you can have a business logic layer, you can have a presentation layer. But this all the modules, like your patient registration is one module, your billing is another module, your clinical SOAP functionality module is another one. This everything is built in one single software. So challenge of that is basically when you are sort of making any change in that system, you need to sort of in fact, I will speak more in detail about that. You need to retest the entire application, because a single change in one module, you need to test the complete application, all the modules. Similarly, if you are managing the deployment of that application on cloud, the entire application you will bundle as a var file or as a jar file, whatever, and you will host it on the cloud machine. Nowadays we are using EC2 machine, or on the AWS, or we are using Dockers or Kubernetes. But the challenge in that is, if load is coming to everything, it is a single point of entry. Basically, you have a controller layer somewhere, and through that your all the web request to your software comes in, and then it is routed to the different modules. And these modules are very closely coupled to each other, tightly coupled to each other. So fundamentally, if you are sort of managing the load on that application, so what you will do? You will increase more RAM, more memory of that machine where you have deployed the software, or you will increase more processors. But that is all vertical scalability. Horizontal scalability, how will you do? Horizontal scalability, you need to partition the application, and you need to deploy the partitions across different applications. So for that, you need to break the application. You need to break your billing module separate, your patient registration module separate, your clinical module separate, your inventory module separate, and you can host all these modules, on the separate machines. So what is the advantage of that? The advantage is, suppose you have broken down your application into different modules, and each module you have deployed on a different machine with a different database, with a different server. Then if you are facing more orders are coming in your system, in your application, and your order functionality module is deployed on a particular machine, so you can increase a more number of that machines, rather than increasing the other machines where your inventory is hosted, or where your patient registration is hosted. You will increase the capacity of those machines where your order module is deployed. Similarly, if you are getting more and more patients getting registration, in that case, you will increase the capacity of the machine where your patient registration is deployed. So that is, and then also you can deploy your patient registration module instead of one machine. You can deploy it in on 2 or 3 different machine nodes, and you can put a load balancer in front of that. So your load balancer will, at a runtime, it will balance the load. Whenever the load increases, it will balance the load. It will distribute the load using DNS algorithm, or using round robin algorithm, or whatever. It will distribute the load across the different machines. So that is called a horizontal partitioning of the machine. But for that, you need to design your application in a manner so that you can break it into simple, smaller services, and you can host these services on the different machines, different containers. And this is exactly the microservice architecture. So microservice architecture, you study the complete domain of the application. For example, the entire healthcare domain, how many modules you have, what all modules can be cleanly separated to each other. Like my registration system is not doing anything with the clinical note. Similarly, my clinical module is not doing anything with billing. My billing is not doing anything with the inventory. So these are logically separated modules. So first I need to do a domain analysis. Then I will break these different modules. And then each module I will convert into smaller independent services, which can be hosted on different containers or different machines. And then I need a mechanism, I need a middleware, which we call as an API gateway. So I need a API gateway where I can pass my all requests to the API gateway, and it can distribute the request to the respective machines depending on the request URL which is coming. We call it endpoint. I'm trying to talk it in a much simpler way. So that is exactly the microservice. Microservice architecture is an approach, is architecture style of developing a single application as a set of smaller applications which can run in its own machine or own process, and which can communicate together using simple internet services or the HTTP service. So that is what microservice architecture. And why microservice architecture is recommended? Because that will promote the horizontal scalability part, that will help you to achieve the hyperscaling features of the cloud. That is a cloud first strategy. And why it is saying the mobile first? Because in the API gateway, the same service you have developed and hosted, in the API gateway, I can write 2 kind of outputs, one for the mobile and another for the web. or maybe the third one for IoT. Maybe in future, if IoT will be integrated, it will be IoT. So fundamentally, I need not to change the logic for the entire application design. I will only change the smaller logic. I will change in the API gateway. So that will be achieving the mobile first and the cloud first strategy. And it can be horizontally separated, so it will achieve the greater level of scalability. You can achieve scalability at a district level. You can achieve scalability at the state level to that larger extent. Right now, so what happens is a smaller vendor is hosting the application. Even the 100 users can't manage on top of that. I mean, they start facing the problem, and they're spending quite a effort in DevOps operations, the maintenance and the testing and those kind of things. They are putting a lot of efforts. But once the microservice architecture is adopted, that will take care of. No, why it will handle the maintenance thing? Because if you are making a change in billing module, you will only test the billing module. You will not test registration, because registration module is separate. You will not touch it. And similarly, if you are sort of so you can host you can distribute your resources as per the application requirement. What is your priority in terms of releasing the different features? Based on that, you can prioritize your team size or the team distribution and all. So those kind of advantages come with the microservice. Next slide. Next slide. I think this I have already spoken. So one of the important feature is microservice architecture. Each service has its own database, and it should be, because you are separating it from the other modules and deploying it separately, independently. So it has its own database. It has, so the only point where all these different services are connecting is the API gateway. So API gateway, you are registering the endpoints basically of all these services. And so it is also, it has a discovery mechanism in that. So even it is not tightly coupled there. Only what you are doing is in the discovery server, you are registering all the services. And the discovery client, the API gateway has the discovery client. It is discovering all the endpoints. Okay, this request is related to billing, where it should go. It is deployed on that machine. So it will route the request to that machine. This request is related to inventory. So it will send it to the inventory related server. So that kind of routing logic is implemented in the API gateway. But rest, your services are separate, your database is separate, and all these are independent services. So that is a way of developing a microservice. Next slide. So as we have already touched upon the point, monolith application is hard to implement, hard to modify. If you make change in one part, it may require the complete rebuilding, testing, deployment, everything. And your entire application will be a single WAR file. We call it WAR file or jar file. So this entire application will be a very overloaded container, web container. The entire application you will build using only one single technology, whether it is Java, PHP, whatever, .NET. And it can handle only the vertical scalability. There is a scalability risk. If more and more growth of load happens on the machine, it may fail. So it has a limitation on that. So it's not a scaled application. Because nowadays we talk about designing the applications at a scale. So whenever you want to design application at a scale, microservice architecture is a necessity, not a choice. Yeah, next slide. So these are the different benefits. Some of them we have already spoken. So one is each and every module that you divide, it is very small, and it is basically divided not based on technology. It is divided based on the business functionality. What business functionality can independently exist from others. So that business functionality is considered as one microservice. And for example, clinical notes, SOAP node. So maybe one way is you can design the entire SOAP node as one microservice, or maybe within that, the subjective, objective, consultation, and plan, each component you can divide as a separate microservice. So that is the granularity to the point, what point you want to kind of segregate the different functionality. Then fault isolation. So if something goes wrong in registration, it will not stop your billing, because billing is separate from registration. Polyglot persistent, because each and every microservice has its own database. So you may choose any kind of database. not necessarily one database technology only. You may choose SQL Server, or you may choose Oracle. Some place you may choose MongoDB or some NoSQL database. So depending on your requirement. So if I'm getting a prescription, for example, in a teleconsultation, if I'm generating a prescription, the entire e-prescription, I can store it as a JSON object in a MongoDB. So no need of having a database for that. No normalization rules are required for that. Similarly, you can scale your team. I already discussed. You can plan. You have only 5 developers and you have to develop. You have 3 important topics in front of you. You need to roll out. Which one I roll out, basically? So you can prioritize, basically, and you can put, one of each of the 5 members on the different module if you want. So that kind of parallel distribution can happen. And compliance to NDHB standards. So it is one of the important guideline, which is defined by India architecture and the NDHB. And within that microservice design, what Access Health, as Access Health we have done, in the design we have considered the different standards that need to be part of that, the MDDS standard and the different terminology standards, and the different other security and privacy related standards that should be part of the microservice architecture based on NDHM guidelines. Yeah. So it is loosely coupled, it's cleanly segregated separation of the different services. Each service has its own, and you can use different technology to develop it. This is the best advantage. You can develop a registration module in PHP, you can develop a billing module in Java, and you can develop inventory module in .NET. So that kind of flexibility also you have. But ultimately, the main advantage and the single most advantage of using microservice is to achieve a highly scalable design architecture. So whenever you want to design application at scale, you should use microservice. And by cloud first strategy and mobile first strategy will be part of the microservice design implementation. So that was the presentation. If you have any questions, please feel free to ask those questions. Over to you, Dr. Pankaj.
Thank you, Krishan. We can join the link. Go ahead, Dr. Pankaj.
No, nothing to add. Pretty well covered. So I guess we can go to questions.
Yeah, so please join the meet link and we can take up all the questions on that.